Let's begin by exploring consciousness in depth. We've touched on the basic question, what is consciousness? But this is only the surface of a much larger and more complex debate. When we talk about consciousness, we're not just referring to being awake or aware. We're talking about the rich, subjective experience we all have, the colors we see, the sounds we hear, the emotions we feel, and the thoughts that flow through our minds. Now, many scientists and philosophers have debated whether consciousness can be explained purely in physical terms. This brings us to what's known as the mind-body problem. The ancient Greeks discussed this extensively. Plato, for instance, believed that the mind and body were distinct. The mind, he thought, was something more ethereal, more abstract than the physical body. Later, René Descartes famously argued that the mind and body were two separate substances. His famous saying, "I think, therefore I am," suggested that the mind, or soul, was something entirely different from the physical brain. But modern science, especially neuroscience, challenges this idea. Today, most scientists see consciousness as a product of the brain. If you damage certain parts of the brain, a person may lose aspects of their personality, memory, or consciousness itself. This has led to the theory that the brain is a kind of biological computer, neurons firing electrical signals and processing information. Here's where things get interesting. A computer processes data too, but it doesn't know it's processing data. It doesn't have a subjective experience. A computer can perform complex calculations, recognize patterns, and even respond to stimuli, but it's not self-aware. It doesn't feel pleasure, pain, joy, or sorrow. So, how can a collection of neurons, which we understand as physical objects, produce the subjective experience we call consciousness? This is what philosopher David Chalmers called the hard problem of consciousness. The hard problem isn't about how neurons fire or how we process visual stimuli. It's about why we have subjective experience. Why is there something it's like to be us, rather than just processing information robotically? Let me give you an example. Imagine looking at the color red. We know that light of a certain wavelength hits your eyes. Your brain processes the information, and you identify the color as red. But why does that light create a subjective experience of redness? Why does it feel like something to see red? A famous thought experiment called the philosophical zombie explores this further. Imagine a person who behaves exactly like a normal human. They walk, talk, laugh, and cry. They even respond to stimuli just like you or me. But inside, they have no subjective experience. There's no inner life. They're just going through the motions. In theory, it's possible for someone to be a zombie like this. But the very idea shows us how mysterious consciousness is. Why do we experience life from the inside? Neuroscientists are working hard to understand how the brain generates consciousness. But we're still far from a complete answer. Some researchers have tried to map parts of the brain to different mental functions. We know that the visual cortex processes visual information, and that the prefrontal cortex is involved in decision-making. But this is only the beginning. There's no part of the brain we can point to and say, that's where consciousness happens. One theory that has gained traction is the integrated information theory, IIT, which suggests that consciousness arises when a system has a high degree of integrated information, meaning it can combine different pieces of information in complex ways. But IIT is still just a hypothesis, and it doesn't fully explain why conscious experience feels the way it does. Another fascinating question is whether other animals are conscious. If you've ever owned a dog or a cat, you've probably wondered, does my pet have thoughts? Do they experience joy, fear, or pain the way I do? We know that animals have brains similar to ours, but that doesn't necessarily mean they experience the world in the same way. For example, chimpanzees, which are closely related to humans, show many signs of intelligence. They can solve puzzles, use tools, and even communicate in basic ways. But are they self-aware? Do they have a sense of their own identity? There have been experiments that suggest animals like chimpanzees and dolphins are self-aware. In the famous mirror test, animals are marked with a dye on their face and then placed in front of a mirror. If they touch the mark, it's taken as evidence that they recognize themselves, which indicates some level of self-awareness. But what about smaller creatures, say a worm or a fly? Are they conscious? These creatures have nervous systems, but they are much simpler than ours. Could their brains, however basic, produce some form of consciousness? And where do we draw the line? Bacteria, for example, don't have brains. But what about more complex life forms, like octopuses, which have distributed nervous systems spread throughout their arms? These questions force us to confront the limits of our understanding. As of today, consciousness remains a mystery, and it may well remain so for a long time. Despite advances in neuroscience, the subjective nature of experience, the what it feels like, part of consciousness, seems to evade scientific explanation. We may one day understand all the processes of the brain, but the subjective experience of being alive might always be a step beyond. Now let's move on to another great mystery: free will. Are you really free to make choices, or are your decisions simply the result of cause and effect? Let's think about it. Every day you make decisions. You decide what to eat, what to wear, and whether to keep listening to this lecture. But are those decisions really yours? Or are they just the inevitable result of brain chemistry and external circumstances? Determinism is the idea that everything in the universe, including human thought and action, follows a strict chain of cause and effect. Every event is caused by previous events, which in turn are caused by earlier events, stretching all the way back to the beginning of time. If determinism is true, then everything that happens is the only thing that could have happened. It means that the choices you think you're making are just the result of neurons firing in your brain, which are in turn caused by chemical reactions, which are caused by your environment, and so on. One way to think about determinism is like a domino effect. Imagine a long line of dominoes. Each domino represents an event, and when one falls, it inevitably knocks over the next one, and so on. In a deterministic universe, you're just a part of this chain. You think you're deciding which domino to knock over, but really the dominoes are already set up, and your action is just the next inevitable step. Now, neuroscience has some interesting things to say about free will. Studies have shown that your brain actually makes decisions before you're consciously aware of them. In one famous experiment, researchers monitored brain activity while subjects were asked to press a button whenever they felt like it. What they found was astonishing. Brain activity corresponding to the decision to press the button occurred several seconds before these subjects consciously decided to press it. This suggests that our brains are making decisions behind the scenes, and our conscious mind is just catching up. But if our decisions are determined by our brain chemistry, does that mean we're just robots following a program? Some philosophers argue that determinism doesn't necessarily eliminate free will. After all, even if your brain is influenced by past events, it's still your brain making the decision. In this view, free will is about being able to act according to your desires and preferences, even if those desires are ultimately determined by things outside your control. Others take a more hardline view. If everything is determined by the laws of physics, then we don't really have free will at all. We're just along for the ride, experiencing the illusion of choice. But here's where things get interesting. Determinism might not be the whole story. When we zoom in to the level of atoms and subatomic particles, things get weird. According to quantum mechanics, particles don't follow strict rules of cause and effect. Instead, they behave probabilistically. We can't predict exactly what an electron will do at any given moment. We can only predict the probability of different outcomes. Some have argued that this randomness could provide a way out of determinism. If the brain is influenced by quantum processes, then maybe our decisions aren't entirely predictable. Maybe there's some room for randomness, and with it, free will. But here's the catch. If our choices are based on random quantum events, does that really count as free will? Isn't that just replacing one kind of determinism with another kind of randomness? There are several different philosophical approaches to free will and determinism. Some philosophers argue for compatibilism, the idea that free will and determinism can coexist. According to compatibilism, even if everything is determined by prior causes, we can still be said to have free will as long as we act according to our own desires and intentions. In other words, you're free as long as you're doing what you want, even if what you want is determined by something outside your control. On the other side, we have incompatibilists, who argue that free will and determinism cannot coexist. If determinism is true, then we can't really have free will, because our actions are ultimately caused by things we didn't choose. They argue that true freedom would require the ability to make decisions independently of any prior causes, which seems impossible in a deterministic universe. Why does this matter? The question of free will has profound implications for how we view responsibility, ethics, and even the legal system. If we don't have free will, can we really be held accountable for our actions? If your decisions are the inevitable result of brain chemistry, upbringing, and environment, is it fair to punish you for something you had no control over? Some philosophers and neuroscientists argue that our legal and moral systems will have to change as we learn more about the brain. If we're not truly free, then concepts like guilt and punishment may need to be replaced with ideas of rehabilitation and treatment. Once again, we're bumping up against the limits of human knowledge. We may never fully understand how free will works, or whether it even exists. But that doesn't mean we should stop asking questions. Free will is one of the oldest debates in philosophy, and it's likely to continue for centuries to come. Now, let's take a step back and look at the universe as a whole. The universe is vast, truly mind-boggling in its size and complexity. Our galaxy, the Milky Way, contains hundreds of billions of stars. But that's just one galaxy. There are billions of galaxies in the observable universe, each with billions of stars, many of which likely have planets orbiting them. But how did all of this come into being? The prevailing theory is the Big Bang. According to this theory, the universe began about 13.7 billion years ago as a tiny point of infinite density, what we call a singularity. At that moment, all of space, time, and matter exploded outward, creating the universe as we know it. Now, let's talk about time for a moment. Before the Big Bang, there was no time, at least not in the way we understand it. Time and space are intertwined, and they both came into existence at the moment of the Big Bang. This is an idea that comes from Einstein's theory of relativity, which showed that time and space are not separate entities. Instead, they are part of a single, four-dimensional fabric called space-time. This means that asking what happened before the Big Bang doesn't really make sense. Time itself began with the Big Bang. There was no before because time as we know it didn't exist. This is a difficult concept to wrap our minds around because we're so used to thinking of time as a continuous, linear progression. Naturally, one of the first questions people ask when they hear about the Big Bang is, what caused it? What set the universe in motion? But here's where we run into a problem. If time didn't exist before the Big Bang, then there was no before. There was no time in which a cause could have existed. This is one of the great mysteries of cosmology, and it's a question that might be forever beyond the reach of science. But let's talk about what happened after the Big Bang. The universe began expanding rapidly, and it continues to expand to this day. In fact, the farther away a galaxy is from us, the faster it's moving away. This was first discovered by the astronomer Edwin Hubble in the 1920s, and it led to the realization that the universe is not static. It's dynamic and ever-changing. And here's something even stranger. Not only is the universe expanding, but the rate of expansion is accelerating. This was discovered in the late 1990s and has led to the hypothesis of dark energy, a mysterious force that seems to be pushing galaxies apart. We don't know what dark energy is, but it makes up about 70% of the universe. The rest is made up of dark matter, another mysterious substance that doesn't emit light and can't be seen, but whose gravitational effects can be observed. So, when we look at the universe, we're only seeing a small fraction of it. Most of the universe is made up of dark matter and dark energy, neither of which we fully understand. This is another boundary of science. There is so much out there that we haven't yet discovered, and we may never fully understand the fundamental nature of the universe. So, where is all of this heading? What is the ultimate fate of the universe? There are several possibilities, but one of the most widely accepted is the idea of the heat death of the universe. If the universe continues to expand at its current rate, eventually all of the stars will burn out, and the universe will become a cold, dark, and lifeless place. Over time, even the remnants of stars, black holes, neutron stars, and white dwarfs, will decay, and all that will be left is a vast, empty void. But there are other possibilities. Some theories suggest that the universe might eventually collapse in on itself in a big crunch, reversing the expansion and returning to a singularity. Others propose that the universe might undergo a series of expansions and contractions in a kind of big bounce. And still others suggest that our universe might be just one of many in a vast multiverse. The idea of a multiverse is one of the most fascinating and speculative areas of modern cosmology. According to some theories, our universe is just one of an infinite number of universes, each with its own set of physical laws. Some of these universes might be very similar to ours, while others might be radically different, perhaps even with completely different laws of physics. The multiverse theory is compelling because it offers a solution to one of the biggest puzzles in cosmology. Why does our universe seem so perfectly tuned for life? the physical constants that govern the universe. Things like the strength of gravity, the charge of an electron, and the rate of expansion are all finely tuned in such a way that life can exist. If any of these constants were even slightly different, the universe would be either too chaotic or too stable to support life. Some scientists argue that this fine-tuning is evidence of intelligent design, that the universe was created with life in mind. But the multiverse theory offers a different explanation. If there are an infinite number of universes, each with different physical laws, then it's not surprising that one of them would happen to have the right conditions for life. We just happen to be living in that lucky universe. The problem is, if other universes exist, they are completely separate from ours. By definition, they are outside our observable universe, so we can't see them, measure them, or interact with them in any way. This means that the multiverse theory might be impossible to test scientifically. It's a fascinating idea, but it might also lie beyond the boundaries of what science can prove. Now, let's turn to a question that has captivated human imagination for centuries. Are we alone in the universe? The search for extraterrestrial life is one of the most exciting and mysterious frontiers of science. Let's start with our own solar system. We know that life, as we understand it, requires a few key ingredients: water, a source of energy, and the right chemical elements. Earth, of course, has all of these in abundance, which is why it's teeming with life. But what about the other planets in our solar system? Mars is the most obvious candidate for hosting life. In the past, Mars had liquid water on its surface, and today there are still traces of water ice at the poles and beneath the surface. NASA's rovers have been exploring Mars for years, looking for signs of life, past or present. So far, we haven't found any definitive evidence of life, but that doesn't mean it's not there. Some scientists believe that microbial life could still exist beneath the Martian surface, where it's protected from the harsh radiation of space. Then there's Europa, one of Jupiter's moons. Europa has a thick layer of ice on its surface, but beneath that ice, there's strong evidence of a liquid ocean. This ocean is kept warm by the gravitational interactions between Europa and Jupiter, which create tidal forces that heat the moon's interior. Could there be life in this subsurface ocean? It's possible. In fact, some scientists believe that Europa is one of the best places in the solar system to look for extraterrestrial life. But if we really want to find intelligent life, we need to look beyond our solar system. In recent years, astronomers have discovered thousands of exoplanets, planets that orbit stars other than the Sun. Some of these planets are in the habitable zone, where conditions might be right for liquid water to exist. One of the most exciting discoveries in recent years is the discovery of Earth-sized exoplanets in the habitable zone of their stars. These planets are the most likely candidates for hosting life as we know it. But finding life on an exoplanet is incredibly difficult. These planets are so far away that we can't directly observe them in detail. Instead, we have to rely on indirect methods, such as measuring the light that passes through a planet's atmosphere as it transits its star. This can tell us something about the composition of the atmosphere and whether it contains gases like oxygen or methane, which could be indicators of life. But here's the big question. If the universe is so vast, and there are so many potentially habitable planets out there, why haven't we found any signs of intelligent life? This is known as the Fermi paradox, named after the physicist Enrico Fermi, who famously asked, "Where is everybody?" There are several possible explanations for the Fermi paradox. One possibility is that intelligent life is extremely rare. Perhaps it's incredibly difficult for life to evolve, or perhaps civilizations are short-lived and destroy themselves before they have a chance to make contact with other species. Another possibility is that intelligent civilizations are out there, but they're too far away for us to detect. The distances between stars are immense, and even if there are civilizations in our galaxy, it could take thousands or millions of years for their signals to reach us. So far, SETI hasn't found any definitive evidence of intelligent life, but that doesn't mean we should give up hope. The universe is vast, and we've only just begun to scratch the surface of what's out there. It's possible that we simply haven't been listening long enough, or that we're looking in the wrong places. But let's imagine for a moment that we do find intelligent life. What would that mean for humanity? How would we react to the knowledge that we're not alone in the universe? Some scientists believe that discovering extraterrestrial life would be one of the most profound moments in human history. It would force us to reevaluate our place in the universe, and it could have far-reaching implications for science, philosophy, and religion. But others are more cautious. What if the extraterrestrial life we find isn't friendly? What if they're far more advanced than us and see us as a potential threat, or simply as a curiosity? The late physicist Stephen Hawking warned that contacting an advanced civilization could be dangerous. He compared it to the European colonization of the Americas, which didn't turn out well for the indigenous peoples. For now, the question of whether we're alone in the universe remains unanswered, but the search continues, and with each new discovery, we move one step closer to finding out. Finally, let's take a moment to reflect on what we've discussed today. We've explored consciousness, free will, the nature of the universe, and the possibility of extraterrestrial life. And in each case, we've encountered profound mysteries, questions that may never have clear answers. One of the themes running through all of these topics is the idea of limits. Limits to what we can know, limits to what we can understand, and limits to what science can explain. Science has brought us incredible knowledge, from the inner workings of the brain to the farthest reaches of the cosmos. But there are questions that lie beyond the reach of our current tools and methods. Does this mean we should give up? Of course not. The pursuit of knowledge is one of the most important and rewarding aspects of being human. Even when we encounter boundaries, we push against them, trying to expand the horizons of what's possible. But it's also important to recognize that there may be questions that science can't answer. Some mysteries may lie forever beyond our grasp, and that's okay. The fact that there are mysteries in the universe is part of what makes life so fascinating. So, as we continue to explore the unknown, let's remember that science is not just about finding answers. It's about asking questions. It's about curiosity, wonder, and the desire to understand the world around us. And as long as we keep asking questions, the journey will never end. Thank you for joining me today on this exploration of the boundaries of science. I hope it has inspired you to keep questioning, keep exploring, and most importantly, keep wondering.